Grace Hopper was one of the most influential figures in the history of computing, a mathematician, computer scientist, and U.S. Navy Rear Admiral whose ideas permanently changed how humans interact with machines. Born in New York City in 1906, she displayed exceptional curiosity and intellectual independence from an early age, famously dismantling household objects to understand how they worked, a habit that foreshadowed her future approach to technology. She pursued mathematics at a time when scientific careers for women were rare, earning a bachelor's degree from Vassar College, a master's degree from Yale University, and eventually a Ph.D. in mathematics in 1934, an extraordinary achievement for a woman of her era. When World War II began, Hopper joined the U.S. Navy Reserve, motivated by a sense of duty and a desire to apply her mathematical skills to real-world problems, and she was assigned to work on the Harvard Mark I, one of the earliest electromechanical computers. Working with the Mark I exposed her to the immense potential of computing, but also to its severe limitations, as programming was slow, rigid, and required deep technical knowledge of the machine's inner workings. Rather than accepting these constraints as inevitable, Hopper began to imagine a future in which computers could be programmed using words and symbols closer to human language, allowing many more people to use them effectively. This vision directly challenged the dominant belief of the time that computers could only understand numerical machine code and that programming would always remain the exclusive domain of specialists. Hopper's most revolutionary contribution came with her development of the first compiler, a program capable of translating human-readable instructions into machine code, a concept initially met with skepticism and resistance, but ultimately recognized as one of the foundational breakthroughs of computer science. Building on this idea, she led the development of FLOW-MATIC, one of the first English-like programming languages, specifically designed for business and data processing rather than purely scientific calculations. Her work strongly influenced the creation of COBOL, a standardized programming language intended to be readable, portable, and usable across different machines, which played a critical role in expanding computing into government, finance, and commercial sectors, and remained in widespread use for decades. Alongside her technical innovations, Hopper became known for her talent as a teacher and communicator, able to explain complex concepts with clarity, humor, and practical examples, making her a powerful advocate for new ideas in a conservative technical culture. She is also associated with the popularization of the term debugging, linked to a famous incident in which a moth trapped inside a computer caused a malfunction, symbolizing her pragmatic approach to problem solving. Despite facing repeated barriers due to her gender, age, and unconventional ideas, Hopper persisted throughout a long career that spanned academia, industry, and the military, eventually retiring from the Navy as a Rear Admiral, one of the oldest active-duty officers at the time. In her later years, she became a celebrated public speaker, inspiring generations of programmers and engineers with her emphasis on innovation, adaptability, and the importance of questioning assumptions, often reminding audiences that the most dangerous phrase is, "We've always done it this way." Grace Hopper's legacy lies not only in the technologies she helped create, but also in the philosophical shift she championed, moving computing away from machines toward people, and laying the groundwork for the accessible, language-driven software that defines the digital world today.